Lines of symmetry have common shapes. Line segment. A line segment has two lines of symmetry. The line lying on the segment on the particular back of the segment line has infinite lines of symmetry. Central line has infinite line. Therefore, each line perpendicular to the given line divides it into two symmetrical parts. Besides this, a line is also symmetrical to itself. An angle having equal lengths has only one line of symmetry. The line of symmetry, the internal bisector of the angle isosceles triangle. In isosceles triangle is symmetrical about the bisector of the angle included between the equal sides, which incidentally is also its median. Rectangle. A rectangle has two lines of symmetry, one vertical and the other horizontal, each joining the midpoints of the opposite sides. Rhombus. A rhombus is a symmetrical about its segments, therefore it has two lines of symmetry. A kite has only one line of symmetry. It is octagonal, obtained by joining properties formed by intersection of equal sides. Isosceles trapezium. In an isosceles trapezium, where one pair of parallel sides and the other pair of non-parallel equal sides, it has only one line of symmetry, the line joining the midpoints of the two parallel sides. Semicircle has only one line of symmetry, the perpendicular bisector of the diameter on which a semicircle is drawn. Lines of symmetry of some bonds. A polygon is a closed figure formed by line segments joining only at their end points. The minimum line segments required to make a polygon is 3. A polygon made up of 4, 5, 6 sides is known as equilateral, pentagon, hexagon, respectively. A polygon is said to be regular if all its sides are equal and all its angles have measure. An equilateral triangle and a square regular polygons of 3 and 4 sides respectively, or regular polygons have multiple lines of symmetry. In fact, a regular polygon has a very lines of symmetry has the number of its circles very high. An equilateral triangle has 3 lines of symmetry. Each line of symmetry is median of a triangle. A square has 4 lines of symmetry, 2 along the diagonals and other 2 along the line segments joining the midpoints of the opposite sides. A regular pentagon has 5 lines of symmetry. Each one of them is a perpendicular drawn from the vertex to the opposite side. A regular hexagon has 6 lines of symmetry, 3 along the diagonals joining the opposite vertices and other 3 along the segments joining the midpoints of the opposite sides. Each line of symmetry passes through the center. On the basis of above discussion, we conclude that the number of lines symmetry of a regular polygon is equal to the number of its sides. Line symmetry and reflection. As discussed earlier, the concept of line symmetry is closely related with reflection. A figure has a line symmetry if one half of it is a mirror image of the other half. Thus, line symmetry is also known as reflection symmetry. If we are given one half of the pair and the line of symmetry, we can complete the pair by keeping along the lines of symmetry. Translation symmetry. In translation, every point of the figure moves the same distance in the specific direction. Along this detail, figures have translation symmetry if the above mentioned property is satisfied. Translation symmetry. In translation symmetry, every point of the figure moves the same distance in the specific direction along a straight line. Figures have translation symmetry if the above mentioned property is satisfied. Translation side. When a geometrical design or motif is created by sliding or translating an original figure repeatedly as shown, we say that the pattern exhibits translation symmetry. Draw all possible answers symmetry. Apply some words given below. E X A C T. Rotation. Rotation is the circular movement of an object about a point in our day-to-day life. Become across objects which rotate around a point, such as a bicycle wheel, blades of a ceiling fan, blades of a windmill. The fixed point about which the object rotates is called the center of rotation. There are two types of rotation: clockwise, anti-clockwise, clockwise. If rotation of an object is in the direction of motion of the hands of a clock, it is called clockwise rotation. If an object rotates in the direction of movements, direction of motion opposite to that of hands of a clock, it is called anti-clockwise rotation. Anti-angle of rotation. The minimum angle through which an object or a figure rotates about this point to coincide with itself is known as the angle of rotation. Angle of rotation. An object is said to take a full turn if it rotates by 360 degrees. A half turn means rotation by 180 degrees, and a quarter turn means rotation by 90 degrees. Rotational symmetry. A figure is said to be a rotation if it fits into itself more than once during a full turn. Rotation through 360 degree. Let's consider the words of parmarth A, B, and C. As shown in figure first, now rotate the pen about point O in clockwise direction when the pen is rotated by 120 degree. When the pen is rotated by 120 degree, that is 1/3 of 360 degree. The blade A takes the position of blade B. Blade B takes the position of blade C, and blade C takes the position of blade A. As shown in figure second, we observe that figure 2 looks exactly the same as the original figure 1. One more rotation about 120 degree brings the blade to a new position as shown in figure third. Finally, after a third rotation by 120 degree, blades of pen come back to their original position. Figure first, figure 2, figure 3, figure 4, figure first 120 degree, figure 2 120 degree, figure 3 120 degree, figure 4 360 degree. Thus, it is full turn. There are precisely 3 portions of rotation. Through the angles 120 degree, 2 degree, and 60 degree, 360 degree. When the pen looks exactly the same, because of this, one can claim that a pen has a rotational symmetry order 3. Now, we give a formal definition of order of rotational symmetry. Order of rotational symmetry. The number of times a figure looks exactly the same as its original shape in a complete turn rotation of 360 degree is called the order of rotational symmetry. Thus, rotational symmetry 360 degree angle of rotation. The rotational symmetry for the lateral edge. The lateral edge is rotatory clockwise direction and collision on the two. Clear pass shows the original position of the lateral edge. Figure 2 shows the position of lateral edge after rotation of 180 degree from its original position in clockwise direction. It looks like it's shape. He also tried the lateral edge has exactly the same twice in a complete revolution of the 3D. Hence, the order of rotational symmetry is 2. Line symmetry and rotational symmetry. We have learned about various shapes and their symmetries. Some of the figures discussed in the chapter have only line symmetry. For example, the letter A. Some do not have line symmetry but only rotational symmetry. For example, a parallelogram and some like rhombus have both line symmetry as well as rotational symmetry. Let's consider the shape of regular pentagon. It has 5 lines of symmetry. Does it also have rotational symmetry? A little thinking leads us to a result. Yes, its order of rotational symmetry is 5. A circle is a perfect here because it has unlimited number of lines of symmetry and at the same time it can be rotated around its center by an angle and still